Anyway, so Manish, thank you so much for joining us. If you want, you can tell us a little bit about yourself, what you're doing, and then you can get started with your presentation.
Right. Thank you so much for a wonderful introduction of mine and to everybody present here. So I'm Manish. I am work right now, currently working on the biomass and plastic pyrolysis gasification, that is converting waste product into something meaningful. I'm converting it into oil and so on. So my basic focus and the objective is to create sustainable environment to cope with the climate change. And in today's presentation, I will be talking about the same. We will talk about climate change, like what exactly is climate change. We will also introduce about like greenhouse effects and the use of several renewable energies to mitigate those problems. And by the end of this presentation, I will be also dealing with some of the sustainable goals that many countries agreed upon to work on it. So let me share my presentation. So while sharing, I would love to hear any questions. I'm always open to questions. Please feel free to question me as much as you can, because that's the way how we can make this presentation more engaging as well. And it might be a little bit fruitful to you as well if you ask as much as questions, so that I would be able to deliver more on it as well. So let me slide. So I think host would enable me to share my screen, please. All right, so let's start.
Let's talk tomorrow in a meeting. Thank you.
Okay, so once again, I'm Manish. And today I'll be... Okay, let me go on. So I'll be basically talking about mitigating climate change and achieving sustainable goals through renewable energy. So before we dive straight into the topic, I just want us to be very clear about what exactly is climate change. So before talking about climate change, from the name itself or from the word itself, it's change in the climate. But what do we actually mean by climate? When we talk about climate, we often hear about weather as well. So let us first distinguish what climate is and what weather is. So when we talk about weather, it's something that you look outside today, or today weather is sunny, or today weather is rainy, could be rainy, sunny, and so on. So whenever we talk about weather, we talk about a very short period of time. So it could be minutes, hours, and we could see that there are several weather predictions that is based on climate. Whereas when we talk about climate, it's a long range of time, basically like 10 to 30 years of time. It's a decades of time. And when we talk about climate change, we are not actually worrying about today it's sunny, tomorrow it will be rainy, there is a change in weather. We are not basically worrying about that. Our basic worry is about climate. That is, we are being worried about the change in the climate that has been for decades. For example, if in this month it's sunny, or if it's summer or it's winter in this month, then we would expect next year at this time to be summer or winter as well. But unfortunately, there is a slight shift in the weather continuously. Like, for example, in the climate that was, or the weather that used to be in January is not the weather that is it right now. The weather in January that used to be 30 years back is not same now. And that is what we are being worried about. So let's talk a little bit more about climate change and its global problem. So before that, we also need to know is climate really changing, or is it just a buzz topic around the world? So let us figure out that. This is the statistics from NASA, that is National Aeronautical Space Administration, where it says that carbon dioxide has gone up to 420 parts per billion. We will later understand why we are worrying about so much of CO2 and why not other gases or something like that. And the global temperature since 1880, we have raised only by 1.01 degrees Celsius, but it has brought us a massive negative impact. It seems very low number, but it has caused a number of problems. So it's going further. Okay, so there are many other statistics which clearly shows us that there is a climate change, because these numbers are the proofs for that. Now let us talk a little bit more about climate change.
I'm not hearing.
Dioxide.
You are not hearing?
That took off during the Industrial Revolution. We started breaking CO2 records in
Yeah, now we can listen. Manish, do you want to restart the video?
Yes.
We listened to the last 5 seconds, so if you want, you can restart the video from the beginning if you're able to figure out the sound, because we heard the sound at the end.
Okay, I think I will. Wait, please let me figure that out.
Sure. We didn't hear it at the beginning, and then at the end, the sound started coming in.
So for the video itself, did you hear the sound of video or just my sound?
Yeah, when it first started, I heard like half a second of sound. Then it went silent for like a minute. And then at the last 10 seconds, then we could hear it again.
Okay, all right. I understand. I hope now you will be able to. I'm sorry about that. I hope you will be able to hear it now, maybe.
fix it.
You can hear it, right?
I'm going to take this off with some
Yes.
basics. So
Yes.
bear with me. This is important. Look at this graph. These are the levels of carbon dioxide in our atmosphere over hundreds of thousands of years. But this spike in carbon dioxide at the very end, that took off during the Industrial Revolution. We started breaking CO2 records in 1950, haven't stopped since. Why? Well, scientists say there's a 95% chance that human activity is the cause. We've been burning more and more fossil fuels like oil and coal, which release CO2 to power our homes, factories, airplanes, and cars. There's also a lot more of us. Global population has tripled in the past 70 years. And we're consuming more products from animals that release another pollutant called methane. So all those gases are released into the air, and when sunlight gets into the Earth's atmosphere, some of the heat gets trapped and the planet gets warmer. That's why they call it the greenhouse effect. But the concern is not that the Earth is getting warmer. It's that it's happening far too quickly.
But it's actually the warmest temperature on Earth since the last ice age, 10,000 years ago.
The UN says that right now, our world is about 1 degree hotter than pre-industrial times. That's around the year 1800, which is okay. In fact, the UN says if we warm by 1.5 degrees before the end of the century, we should be fine. The UN even says 2 degrees would probably be all right. But again, the problem is speed, because right now we're on track to hit 1.5 degrees in only 10 years. And if we don't slow that warming down, it could mean catastrophe within my lifetime, maybe yours too. And we're already getting a taste.
Climate change is here. Climate change is happening. We're well into the 6th mass extinction event.
Sure, it's cold, but it's hot.
With the thousands of rescues just in the early morning hours of Sunday.
Millions of people are likely to suffer wasting food and water shut drought. Now, in its 10th year, it's a phenomena that's here to stay.
We've never seen it is worth the rain
7 dives. Sea levels are rising about 3 millimeters a year because seawater expands as temperatures get warmer. Melting ice sheets and glaciers also add trillions of tons of fresh water into our oceans. People around the world are already losing their homes. And if things carry on, millions more of us will have to pack up too. Entire coastal cities could be underwater within 80 years, like Miami in the US or Osaka in Japan. Entire island nations in the Pacific could completely disappear.
Natural disasters becoming more and more intense, more frequent, more devastating. The dramatic impacts of drought, different parts of the world, all this is creating a situation that is a real threat to mankind, and we are not doing enough.
99% of doctors said to you, take this medicine or you will get really sick and die, you would take it. You wouldn't take it. The problem is at the moment, we don't have any medicine.
Now there is a plan to slow all this down. Back in 2016, world leaders signed the so-called Paris Agreement. And the big pledge is to cap temperatures rising by 1.5 degrees or a maximum of 2 before the year 2100. So countries set their own targets on how much CO2 they emit. But here's the thing, 3 years after the agreement, global CO2 levels are still going up.
CO2 emissions have been going up the last year by 2%. So that's actually above the average of the last 10 years. So it's started to increase again, and it doesn't look too good.
In some ways, we're going backwards.
The United States will cease all implementation of the non-binding Paris Accord and the draconian financial and economic burdens the agreement imposes on our country.
The US, one of the world's biggest polluters, has pulled out of the Paris deal. Russia and China are accused of not giving themselves ambitious targets in the first place. Turkey and Poland want to build more plants. And then there's the skeptics.
It's a political decision that is man-made for the whole forced the computer models to say, human influence, CO2 and other stuff.
The ground-based temperature data has been massaged to show an increase, but the satellite data shows no increase.
On the other hand, there is positive momentum. There's more awareness, and some countries are making progress. India, Morocco, and the Gambia have massive renewable energy projects.
So different countries do things successfully. So some countries are, for example, making public transport free in the cities. What a great way to encourage people out of their cars.
But experts say what's needed now is an even bigger push to change everything about the way we run our world.
Business as usual has got to change. Politics as usual has got to change. In order to combat that, we have to change the system that has allowed it to happen. You can't have infinite growth on a finite planet.
And everyone can do that by, shifting to renewable energy, reducing the use of cars, use train more, cycle more, less eat, consume a bit more carefully.
So where does that come? There's only so much bike riding and light bulb replacing that you and I do every day. The truth is that it's those everyday things that are going to change anyway. Even coffee could run out if farmers can't grow it. So the expert advice is that it's down to all of us to change our ways and shake things up. For climate change, it's going to do it for us.
Okay, so I hope that the issue of climate change is well realized by everybody. So I could see there were some hands raising. If you have any question, then I would love to take that. Are there any questions? Okay, let me move ahead. If there is anything, please feel free to type in the chat. I will take that as well, and please speak as well. So that's fine for me. So now by this video, I hope that we are, please.
Excuse me, sir.
Yes, please.
By names of Virunji Moviru, right away from Uganda, that is Africa. Only that the information from that madam was not actually clear due to maybe due to the network. So I am requesting, if possible, she shared a video of what she have been presenting, so that we try to actually to have more knowledge about it. So thank you very much.
So do you want me to send the slides after the presentation?
I think what we can do is maybe if you can share the link to the video in
Yeah,
the chat,
sure,
because
sure.
some of them missed a little bit the audio part, so it was a little bit low, but I still was able to hear it. But I think if you don't have a headset on, it was kind of difficult. But yeah, if you shared with us in the chat, that would be perfect. Thank you for
Okay,
that,
all
Birunji, for sharing. I also see Danielle Noel, you have your hand up. Please unmute yourself and ask.
Okay. Okay, so let me
Daneline Noel, did you have a question? Okay, go ahead, Manish.
okay,
Please
all right.
continue.
All right. So by this time, I hope that some myths about climate change are gone. So first of all, the myth about the earth is, the first myth that people have is earth is warming due to natural causes. That was the myth that many of us had previously, but it is always to realize that it's the human activities contributing equally, like burning fossil fuels and using different activities is causing climate change. The next myth was, so scientists don't agree on climate change. We have seen the statistics in order to wrong validate it, and we could see from this fact that climate change is very real and we must act, we must think about it. So another myth is like life will adapt to climate change, but we have seen in the video that there are many problems that are arisen by the climate change, which we will have to face in the future. The next myth was cold weather plus global warming is not real. So we just saw in the video or my slides that even a 1 degree rise in temperature is a vital problem for us. So even if it is cold at some region, it might be hotter in terms of 1 degree Celsius or let's say 2 degree Fahrenheit. The last myth is that it's too late to do anything. This is also false. We can act, we can have efforts in order to mitigate these climate changes by focusing on the ways that I will be presenting today. So it's the right time to act now. So for mitigating climate change, we need to understand the cause of climate change. So, well, that was explained in the video itself that the real cause for climate change is the greenhouse effect. So when we talk about greenhouse effect, let us understand what exactly is this. So our earth has air, and air has a composition of 78% of nitrogen, 20% of oxygen, and a little bit of carbon dioxide. So if we talk in terms of 1 million molecules, then 780,000 molecules out of 1 million is nitrogen gas. So 209,460 is oxygen gas. And we do have a very little amount of carbon dioxide and methane. And they were actually our friends. Carbon dioxide and methane are actually the reasons why we are surviving here. If it was escaped totally from our earth, then we would not probably live as well, because it would be too cold for us to live in the planet. So they were our best friend before. They were creating the temperature well enough for us to sustain and live. So the carbon dioxide concentration of 381 was safe for us, and it is the most required thing for us. But unfortunately, with the burning of fossil fuels, there is the continuous addition of carbon dioxide, which is the problem. So the friend of ours, which made the life sustainable on Earth, is turning into the devil right now. So CO2, we discussed that the concentration of CO2 is nearly about 500 now, which has increased by more than 100 ppm. So if it is able to, if it keeps on continuing and like that, then it will be a severe hotter planet, and there will be ice melting and lots of calamities that we have seen in the video itself. So it is to be understood that greenhouse effects are very important for us until they are up to a certain limit. But once it exceeds the limit, it becomes a problem. Similarly is with methane gas. So now the idea,
are driving up the Earth's temperature and fundamentally changing the world around us. Increasing the Earth's temperature. Human activity, like the burning of fossil fuels.
so these fossil fuels needs to be controlled.
Hello.
Because
Hello, network. Yeah, tangu.
Warm the planet at an alarming rate. While Earth's climate has fluctuated in the past, atmospheric carbon dioxide hasn't reached today's level in hundreds of thousands of years. Climate change has consequences for
so the idea is that it is because of several our human activities that there is continuous rise in CO2 concentration. And by any of the means, we should plan for the things that would reduce the CO2 emission. Or like, let's say when we move, there is a CO2 emission as well, for which we might need to control. So the idea in order to mitigate climate change is to have as much as less CO2 than it is in the earth. So the idea for controlling CO2 would be to focus on renewable energies. So renewable energies could be our life saviors because they do not emit CO2, or the main cause for CO2 is because of the energy. And for energy, we are now using coal, fossil fuels, because of which there is CO2 emission, and that is causing climate change. So if we transit ourselves into renewable energies, then there will be less CO2, less global warming, and a little bit of climate change only. So we need to focus on renewable energy. So talking about the renewable energy, so let us understand what exactly is renewable energy. So renewable energy is something that can be naturally produced. Let's say we have plants. Plants are always there. We can make plants grow. There is sun. No matter how much energy we get from sun, it's eternal. It could be every day. We can get the energy from sun all the time. Likewise, from water as well. The water can be recycled. The water, the used water goes into the sea, evaporates, gets into the sky, and falls as a rain back into the earth. So it is also renewable energy. But the other sources like minerals, coals, and other different non-renewable fossil fuels are non-renewable. And there is a threat of fossil fuels extinction as well. It is predicted that by 2100, there will be the extinction of fossil fuels, and it would result in the more need of renewable energies. So the common renewable energies that we have now are solar energy, geothermal, solar hot, biomass, small wind, solar space heating, and so on. But these renewable energies have problems in themselves. When we talk about the problems, for building up the solar panels, we need a huge land. And that land and the residue of the solar chips cause the problem. So once we have the solar panel, once it gets exhausted, we cannot use solar panel and we need to throw them, and throwing of that again causes the pollution. And there are many there are many reasons where there is not even continuous sunlight as well, because some regions are filled up with mountains or hilly regions where even getting sunlight is not that easy. So there is a problem with solar as well. Likewise, if we talk about the other different forms of energy that are evolving right now, one of them could be the hydrogen gas. So let's watch this video.
The world uses 35 billion barrels of this massive scale of fossil fuel dependence pollutes the earth, and it won't last forever. Scientists estimate that we consume about 100% of oil. According to present estimates, at this rate, we'll run out of oil and gas in years or so, and in about a century for coal. On the flip side, we have abundant sun, water, and wind. These are renewable energy sources, meaning that we won't use them up over time. could exchange our fossil fuel dependence for an existence based solely on renewables? We've pondered that question for decades, and yet renewable energy still only provides about 13% of our needs. That's because reaching 100% requires renewable energy that's inexpensive and accessible. This represents a huge challenge, even if we ignore the politics involved and focus on the science and engineering. We can better understand the problem by understanding how we use energy. Renewable energy use is a diverse and complex system, and the different elements require their own solutions. But for now, we'll focus on two of the most familiar in everyday life: electricity and liquid fuels. Electricity powers blast furnaces, elevators, computers, and all manner of things in homes, businesses, and manufacturing. Meanwhile, liquid fuels play a crucial role in almost all forms of transportation. Let's consider the electrical portion first. The great news is that our technology is already advanced enough to capture all that energy from renewables, and there's an ample supply. The sun continuously radiates about 173 quadrillion watts of solar energy at the Earth, which is almost 10,000 times our present needs. It's been estimated that a surface that spans several 100,000 kilometers would be needed to power humanity at our present usage levels. So why don't we build that? Because there are other hurdles in play, like efficiency and energy transportation. To maximize efficiency, solar plants must be located in areas with lots of sunshine year-round, like deserts. But those are far away from densely populated regions where energy demand is high. There are other forms of renewable energy we could draw from, such as hydroelectric, geothermal, and biomasses, but they also have limits based on availability and location. Principle, a connected electrical would enable us to transport power from where it's generated to where it's needed. But building a system on this scale faces an astronomical price tag. We could lower the cost by developing advanced technologies to capture energy more efficiently. The infrastructure for transporting energy would also have to change drastically. Present-day power lines use about 6 to 8% of energy they carry because wire material dissipates energy through resistance. Longer power lines would mean more energy loss. Superconductors could be one solution. Such materials can transport electricity without dissipation. Unfortunately, they only work if to low temperatures, which requires energy and defeats the purpose. To benefit from that technology, we need to discover superconducting materials that operate at temperature. And what about the all-important oil-derived liquid fuels? The scientific challenge there is to store renewable energy in a transportable form. Recently, we've gotten better at producing lithium-ion batteries, which are lightweight and have high energy density. But even the best of these store about 2.5 megajoules per kilogram. That's about 20 times less than the energy of 1 kilogram of gasoline. To be truly competitive, car batteries would have to store much more energy without adding cost. The challenges only increase for bigger vessels like ships and planes. To power a cross-Atlantic flight for a jet, we need a battery weighing about 1,000 tons. This too demands a technological leap towards materials, higher, better storage. One promising solution would be to find a efficient way to connect solar.
So it looks like we lost the sound, but it looks like we're at the end of the video. Manish, there is a question from Godwin. Godwin, I saw your hand up. Did you want to ask a question, Godwin? Please go ahead.
Hello? Yeah.
Yes.
Yeah, please move on the question, please. Yeah, let me have the question.
Godwin, I saw your hand raised. Did you have a question or no? Okay, go ahead, Manish.
Okay, let me explain the information that I wanted to share with you in the video. So because despite the sound was not clear, let me clarify what I actually mean. So nowadays there is a transition is renewable energies, which we have figured out, but there are several problems with multiple renewable energies. When we talk about solar powers, then there is the problem that it would need a lot of land for us to keep solar panels. Also, another problem is that not all the places have sunlight all the time. Like even for 12 hours, even for like in winter seasons, even solar panel could be a problem as well. Also, even if we have the solar panels, then we might need it to be on the land which is not settlement or where there will be a free land. But the problem is in the transportation. So we produce the energy, that's very good, but why transporting it from the place from where it is produced, the place where it is needed is a problem. And there are many energy storage devices being researched on and so on. Like, so there, and another problem with renewable energy is that, I hope my sound is coming right now, right? Yeah, okay. So the problem is the transportation. And another problem that the video highlighted was the energy density. Like we might need a lot of substances and we could get a little energy. So that's not what we expect. We expect something having a little would produce more. And there was where electricity or the battery came into the picture. But unfortunately, the material that is used in order to make battery are not that friendly to environment. So it has multiple problems because of battery as well. So once we use the battery, once the battery gets finished, where should we put that? We cannot throw it outside because it causes other greenhouse gases emission, which we do not want. So there should be some other solutions as well. So this is what I wanted to share from the video. So now let's get back into the video. Now, also there were like the hydrogen that came into the picture. The main problem was the energy density, where people find out that the hydrogen is very small in size, but it has a massive power. And it has been used in many applications, like it have been used in pharmaceutical applications, transportation, nuclear energy, electric grid infrastructures, and a lot more. And this energy also had some problem. That is, like it is very energy dense, but once it gets very near to the fire, it blasts off. It could cause a fatal accidents, which might be caused. Yes, please.
No, it's not. It's that one. They have their own small light. Who is this one?
Godwin, do you have any question?
I just wanted to mention, Manish, that yesterday, I don't know how many of today's participants were in the presentation about hydrogen energy. The main issue we saw, one you already covered, which is the combustibility, right? It can explode.
Yeah.
And the other thing was that currently with the current technology, unless you use like a platinum or something like that as the, to electrolyze the water, that the amount of energy used to produce the hydrogen was a net negative at in some cases or in most cases. However, like you mentioned, it's such a condensed amount of energy in a small space that it appears to be the future, and there are already some commercially applicable things, but it's not economically feasible without incentives in most cases. So I don't know what your opinion is on when we might.
I 100% agree to your thoughts. It is very difficult for like in terms of safety, it is very difficult, and there is like other aspects to why like we need to provide more energy is that because it is good, it has a great effect, but the problem is it is very difficult for us to transport. So for transporting energy, we need to compress that energy as well, which would require us more energy. So that's the problem. But with the innovation in compressing and with the heat integration methodology, like we could, so whenever we have the production of hydrogen, we get a lot of amount of extra heat energy as well. And if we are able to utilize that heat for other economic benefit, then it could be an option if we are able to utilize it. The cost prediction that is done right now is with excluding that heat. And since there is a huge cost in compression, transportation of hydrogen energy is not yet developed. So that is the cause for the worry this about the cost of hydrogen energy. So moving on, so my preliminary, and there is other problem with hydrogen as well. So there is gray hydrogen, blue hydrogen, and green hydrogen. So only the green hydrogen is applicable for sustainability. And as you said, like there are several problems in terms of economy and all. So we would be now, another case is like we can't close all the industry. There are CO2 emissions. Let's say if we consider about cement production, then there is a CO2 emissions no matter which energy we use, because calcium carbonate when forming cement decomposes into carbon dioxide as well. And there are many other processes like that. So in order to bring that up, there are many carbon capture technologies. The carbon dioxide, which were our enemies, we can capture it, utilize it into varieties of applications. So it could be used as fuel, it could be used as carbonates, polymers, it could be used in food industry, oil recovery, and so on. So the CO2 that we are worrying about, if it is captured, and it could be used for multiple applications as well. So if we are able to capture it, we can also beat sustainability and create carbon neutral thing. So now the problem is not only with the carbon dioxide. There are many organic wastes that we see inside the landfill. Like the major wastes are organic waste, which consists of 76%, and there is also the plastic waste that we need to worry about. Now we might control that emission, we might use the very latest energy, very dense energy, but the waste are something that gets produced all the time. It might be the food waste that we throw, or it might be the plastic bottles and plastic waste that we throw here and there. So yes, please, there is a question raised. Please go on. Hello, is there a question? Any question?
I think no, we can go on with the meeting.
Okay, all right. So let's go ahead. If there is any question, please feel free to ask. So now I was saying
I
that
just see Alucine Conte. Alucine Conte, I see your hand raised. Did you want to contribute something or ask a question? Okay, let's keep going.
All right. So the problem of the West is that because of the overpopulation, the West keeps on growing and growing and growing. So it has to be a better solution. My idea is to convert the organic portion of the waste into biogas, which could be used as a synthetic natural gas, which would contribute, which is not totally carbon free, but it will be a carbon neutral. So there is the opportunity that we can convert our waste into a resource. And good news about it is the residue that remains, the thing that we cannot convert into oil or the biogas, we could convert it into the char. The char can be used for the agricultural enhancing agricultural productivity as well. It could be converted into manure and many other applications as well. The carbons, the char can be further it can be further upgraded to microchips or pen drives, memory cards, and all of that. And it could be a resource in that aspects as well. Moving on, as we say that there was a hydrogen produced and there is the CO2 emission all the time. And also, because of that, what we can do is we can mix up that carbon dioxide and we can mix up the hydrogen to form biomethane, which could be a liquid fuel as well. So this is also the area of research that is getting very attention these days, because hydrogen is a buzz topic itself, and there is an emission of CO2 a lot. So there is a research about combining CO2 and hydrogen to form a methane as well, which could be a potential solution for the future economy. As we all know that biomass is something that comes from plants and animals, and it could be the waste that comes. We need not cut trees for doing utilizing the biomass, but it is okay for us to utilize only the waste product, something that we do not need, and something that would cause the problem, that would cause CH4 emission, or that could cause CO2 emission. Also, this is the process. So we have the biomass, we have the plastic, so this is the process of heating up the plastic. When we heat the plastic, we get char, which could be used for the agricultural productivity. We can convert the char into chips as well. We can use gas by rotating turbine. We can generate electricity as well. And oil is something that we can use in gas engine, internal combustion engine. And there are many bio-based vehicles that are being generated in Europe, especially. So from plastic waste, it can be converted into a petrol-like substance, which can be utilized in replacing fossil fuels as well. So, but there is a problem with plastic only, because when we burn the plastic, when we pyrolyze plastic, there is one problem, that is it has a lot of tar formation, and we would need to minimize that. So my idea, or the research that I'm doing, is and the next problem with plastic is that it is very difficult for us to segregate. Our municipal waste comes on all at the one place. So it's very difficult for us to separate the waste that goes for biogas and that goes for oil production. So the idea is, and another problem is that the oil, that the petrol or the fuel that we get from biomass cannot be directly mixed with the oil that we get from plastics as well, because there is kind of formation of many other substances which could decrease the efficiency of that oil. So we cannot mix it at the end, but there is research going on where we can mix these substances initially, for which we call pyrolysis. It is the process by which we convert these different waste to a fuel, and there is an enhanced efficiency of that. So there is some synergistic effect. Let's say the oil efficiency that we have, that is produced from biomass only and that is produced from plastic waste only, is much less than what we can get by combining them. So when we combine these biomass waste and plastic waste together, and if we produce some oil or if we produce some fuel, then it has more efficiency than the previous one. And there is additional benefit to it as well. That is, if we need not, so the problem of utilizing it was the segregation. We need to segregate biomass separately. We need to segregate plastic waste separately. And then for the plastic, we need to do it separately. For biomass, we need to do it separately. But the current research focuses on combining them together and having even the better yield. So that's where the world is focusing right now for the production of bio oil. So now, by the time we have discussed a lot about renewable energy emission, controlling CO2 emissions, focusing on renewable energies. We talked about several renewable energies, be it the solar power or hydrogen energy or biofuels as well. And so this is not something few countries agreed. So this is known as sustainable development goals, where there are multiple countries that is focusing on achieving sustainable goals. So the sustainable goals, there are 17 actually, and some of the sustainable goals are no poverty. Yes, please, there is a question, I think. Hello, is there a question? Elder, is there a question?
Yes, yeah, he's trying to unmute. So yeah,
Okay, please. Yeah.
there's a
Okay,
little
can you hear me?
microphone. Yes, yes, go ahead. Please,
Yeah,
Noel
please.
Dar. Noel Dar,
Thank you,
thank you.
Manish, so far, and the rest. Um, before the slide, you mentioned PV, which is something really very common in our days. I also came across what we call solar connectors, which basically do not use any batteries, but they can be utilized to collect the heats from the sun and generate that or manipulate the compressors and condenser so that they can act like electricity, so saving on electricity and also in diesel. I don't know what you think about that. And my second observation before all these things which I very interesting in it because, but it seemed to me that the setback of this process is financials. Are you going to cover that later on, please? Thank you.
Okay, thank you for your question and the suggestions as well. So on that, I would like to go back to one slide and then explain a little bit more about it, what could be done in order to increase the efficiency as well. So whenever we were talking about hydrogen energy, we talked that it was having a lot of financial problem. The more energy we put and less we get. This is what we were worrying about. The energy that was wasted was because of the heat energy that was caused in the electrolysis process. In electrolysis process, there is a huge heat that comes in, which we are not able to utilize. But if we could use that heat and for the production of biogas, we need that heat. So here in the electrolysis process, their heat goes in, but for the anaerobic digestion, we need heat to make biogas, or we need heat for the pyrolysis as well. So if we are able to couple up this process, production of hydrogen, and there is a huge amount of heat that gets out, and if we could utilize that in the places where heat is needed, let's say for pyrolysis or for the biogas production, then that would be beneficial and it could significantly reduce the cost for the production of renewable energy. Also another good news is that the price of electricity and the solar panel, if we see it in the recent time, is getting cheaper and cheaper days by days. So we expect that it will be even more cheaper in future, because there is multiple research going on and there are multiple ways from where we can generate electricity, because there is wind energy, there are many other forms of energy as well, which is being used for the production of electricity, which is making the electricity cheaper and cheaper. So let's hope for the best that the hydrogen energy pyrolysis, which requires the much energy, will be reducing the cost significantly. So this is the future that let's expect that. Did I answer you, or do you have any other questions?
No, I'm fine.
Okay.
Thank you very much.
I think there is another question as well. Godwin, please feel free to ask.
Yeah, thank you. Thank you for this. I came in midway for this conference. I'm calling from Nigeria. The challenge is how to make this available to the greater majority of our population that need electricity. And that requires that your model should be in such a way that it can be affordable, the design can be compactable, and that we can have them in most of the rural areas or urban areas where you have large resource for waste. Presently, there are some research going on to convert waste or biogas from pit toilets or from septic tanks. But I think that the greater problem that we have is the affordability of your equipment that we can use to power the homes or even provide a smaller dimension of electricity. That is the challenge, and I want you to address that. Thank you.
Yeah, very wonderful topic that you brought up, the waste that goes into the toilet to be converted into resource as well. And that is very good point, as I highlighted that. Otherwise, let's before talking about the waste that goes into the toilet, let's talk about the animals that produce such waste as well. So consider this. This is a manure that the cow, or there are a lot of animals that produce. So these are also the cause for methane emission. And we could use not only the food waste, but manure as well. So there is we can mix manure, food waste, all the biodegradable substances and produce biogas. So this is also happening in the world. So otherwise, this is a very good point, and we must focus on that as well, because it is significantly reducing the methane that is being produced. So if we could utilize that, that would be a great idea as well.
Are you hearing me, sir?
Yeah, I'm sorry.
Yes, go ahead.
I'm hearing. Yes.
Yes, one other challenge that I would like this research to address is, can we get usable equipment, a small equipment that everyone can afford to connect to can use in the homes. It is easier to get some of this equipment, but the important thing is, the challenge is, are they affordable? Can we get them in most of these third world countries where we have large deposits of waste? Thank you.
Yes.
Yeah.
Yes. What Godwin mentions is a good point, because in some countries they subsidize these products, the purchase of the implementation of these products. So even though they're not currently feasible economically, the subsidy by the government makes it affordable. And I think the idea, Godwin, is that over time, as it gets more and more adoption, the production of all the equipment, all the materials that make these processes possible will hopefully become affordable enough that it can go throughout the entire world. So I don't know what maybe Manish, you are familiar with some type of setup that could be done by anyone for maybe something under $5,000 or under $1,000 or under $10,000. I don't know if there's I guess some type of a setup where someone in a rural area, maybe in a small complex or a small factory, could benefit from some of these technologies.
Yeah, very interesting point. Let me quickly share you something that is going in my country in the rural areas, for which we call gobar gas. So I would love to share about that as well. So this is. So there are many regions in my villages, especially in the remote areas, they have been using the biogas, and they are not dependent upon LPG anymore. They are using the gas from the waste that they generate from the house itself. So let me show you some pictures, and the cost is it is very less. So these are the small dams they are having at their home, from which they are generating a gas, and it is the real thing that is going on. So these are the very small container, or the household rural areas are also focusing on renewable energy, and they have been using it.
Fantastic. I think that, Manish, those examples are basically, I mean, they're not free, but they're almost free. I mean, the cost of making those is basically labor and a little bit of cement, not too much. So I think that's an excellent example of how we could implement the technology immediately.
Yeah, but it has a low calorific value. It is not that 100% like LPG. but it definitely keeps an eye. It would be a cheaper option if we scale up down, but there would be many other upgradation techniques which will require further costs for sure. But this is what exactly is happening in my country as well, at least. So there are multiple projects we call it biogas, or we call it gobar gas. So it is being happening. So if you could see here, then there is a cooking stove right from the biogas. So this is the biogas. We are getting a gas from here, and this is being cooked here. So we can get some amount of calorific value of gas that can be applied.
Fantastic. And Danielle, I want to call on you. Danielle, Noel, you have your hand raised. Please join us.
Good afternoon, everyone.
Good afternoon.
Yes, I really appreciate the program because we're given an assignment on biomass. I'm calling from Cameroon. Douala precisely. Yes, I have two questions. The first question is like, the presenter, that means Mr. Manish, talk about the renewable energies which could make our life to be safe. I would like to find out, first of all, he said also about electricity. The electricity is produced through solar energy. That could also reduce the price or the amount of the electricity payment. But the fact is that here in our country, the bill of electricity is still very high, whereas we are already using the solar energy. So I don't understand what could be the link with the biomass. Second question, we are talking of biomass, and I did a research according to the assignment that was given to us concerning the fact that I've seen when I was doing the research that biomass is the organic waste. Is the sum of many organic waste. That means the waste from the plants, from animals, from houses, from wood, anyhow, is many waste that could make the residue that is called biomass. So now my question is like, what about the waste that comes from human being after seeds? Because I know that is used also for fertilization, for the plant to grow, for us to have fruit again that we eat and swallow after we reject again. So what about that? Because during the presentation, I've not seen the classification of that particular waste, whereas it's a waste that is useful to the plant. Thank you.
Rick, could you please rephrase the question? I couldn't understand.
Yes, no, please. Sure. Yeah, I think the question was about the different bio wastes, and I think Danielle was mentioning things like plant bio waste, human waste, and all of the, like wood pellets, all types of organic wastes, and that, she's heard of that being used for fertilization of the crops, fertilizing the land of crops. So I think she was asking about, okay, how could we use that for electricity? And I think in your case, your presentation is mostly, Danielle, for using the biomass waste to convert it into like fuel, which could be for powering a stove or maybe powering a generator, which would then make the electricity. So I guess Danielle's trying to make the connection between the biofuel and the energy generation. That's the question.
Okay. So what we can have is, so I think the mark from, so for the biomass that you change it into oil, that is clear, right? And once it is in the oil, we could have it in the stove that I show you, or it could be further converted into other different sources like methanol. And whenever we need it, we may just burn it. And we could, by using that fuel, we might rotate a turbine which would generate the electricity.
Perfect, good. So Manish, could you tell us a little bit about the example you showed us of those, where you put the bio waste inside there? What happens inside of there, and how long does it take to produce the low yield fuel that can then be used for either powering the stove or powering like a small turbine or something to make electricity? Can you explain to us a little bit what's happening there under the ground in that large container?
Okay, so we have a container, we fill in the bio waste there, And from there, let's talk about the LPG first. So how does LPG work? How does LPG light the, from our LPG, we can heat up the things, right? There is a fuel that comes in. So LPG basically contains propane and butane if we go into it. So it contains propane and butane, and from bio waste as well, the gas that we are getting, it's similar in nature to that what we have in LPG. So whenever we have so let's consider an example. Whenever there is a toilet in front of us, it smells bad, right? So the cause for that is because there is the methane that smells bad to us. And that methane, it could have a store, and if we could flow that into the gas, it could burn as well. So the idea is to get all the gases from there at one place, transport it with a pipe, connect it to the stove, and have a fuel, and have that gas particularly work as a fuel.
Fantastic. Yeah, and we could see that those structures were curved like a dome to let the gas rise to a specific point, and then it could be siphoned off somewhere for consumption.
Yes, correct.
Okay, very clear.
Also, I just want to go further on Daniel's question, as he said that bio waste is now being utilized for agricultural productivity just right now as well. But if we do biogas production, and there is a gas that goes in, but there is something that remains in the digester itself. So there is some residue that remains. We could use that into agriculture, which has even more potency than by using it normal. So whenever we use the bio waste directly, is different than what we get from the biogas digester as a residue when we use that. So there is a difference in the productivity that we can achieve.
Fantastic. So is there anybody else that has a comment or would like to share something? I think that's a great point for Danielle, because yeah, it's not only the power from the methane gas that you can use to generate electricity or to heat your stove, but the residue would then be used for farming purposes. So we have multi-use of the same product there. So that's excellent. Okay. Okejo Samuel, I see you raising your hand physically. Go ahead. Let me ask you to unmute. We can't hear you. Okejo Samuel, we cannot hear you. You're still muted. So there's a little microphone on the lower left-hand corner. If you click that,
you can.
Yes.
You can hear me now.
Yes.
Yeah,
go ahead.
yeah.
Yes.
Can hear you. Go on, please.
Yes, I agree and accept the technology being used in other rural areas. Here we are living totally in the rural areas where life is difficult. So the little concern is how safe is the technology being used for the bio waste. I saw the gas was being used for cooking for years. How safe is it? Because I saw those photos, like they were not very hygienic, the hygiene of that technology.
So if we consider the safe part of it, so it has been used properly. It has been used for like 100 years in my country in rural areas. So it is not safe. It is not unsafe because, but all the gases that comes out, we are just taking it from the stove, or we are having a dome size and we are just passing the gas out. Rather than having it, the pollution around us and the pollution that methane goes into our, like we take the methane without having it confined in some region, it is safe process. So in safe uses, it's okay. Unless the contaminants that are like, and the good thing about it is, since we are having it in without oxygen, all the microorganisms gets killed. So we need not worry about microorganisms as well, because it is anaerobic process, which means we are not supplying oxygen to it. So all the microorganisms that we are used to be on that particular bio waste or the waste from toilet gets killed. So they are no more there. So which makes it even more safer. I hope I answered
So
your
it
question.
ideally works on the principle of no leakage.
Yeah, so that might be a difficult problem. Yeah, that is the main frustrating issues on that there should not be any leakage, or like we could have it a little bit far from the settlement area for that, in order to ensure the leakage if there is anything. For the images that we saw, so these let me show you these images again. The images that I showed you previously, so these are a little bit far from the settlement area, and we just get a pipe from it into our home. So see, this is a little bit far from the settlement area, maybe like 100 meters far away from the house itself. So, and we can get a pipe from it, and the pipe is taken not straightly from above, but it is taken from the underground, or something like that, or it could be like managed in that way so that there would be a minimum leakage as well.
Yes, and I don't think there's any additional risk than what we have already been doing with, millions of people who get supplied gas in their homes. So yes, I mean, there's always a slight risk with handling methane since it's flammable, but that has been used by millions and millions of people throughout the world that use natural gas to power their homes. So we have set precautions that can be taken to mitigate those risks. Well, we've reached we've already gone way past the hour, so I really want to first of all thank Manish and for
Yeah, I
joining
think
us
there is
today,
one
for
question
doing the
before.
presentation. Of course,
please.
yes, please go ahead. We have Francis and then HP. So go ahead, Francis, and then we go to HP.
Thank you very much. It's quite an interesting topic. I am from Nigeria. My question has to do with the coal pyrolysis. What is the gasifier going to look like? Secondly, we have a load of waste tires and used waste tires in this country. Are we going to cut them into pellets? What about the fumes from the tires? They are very poisonous. So we have to take all this into consideration. No matter how okay, thank you.
So yeah, so Manish, Francis was asking about the pyrolysis machine. What would it look like? And then he talked about used tires, like rubber tires, that, how could we utilize those? Maybe chop them up and put them in the pyrolyzer. Maybe you can tell us a little bit about that.
Yeah, very interesting question. As he was like saying about the fumes as well, we get a lot of fumes from tires and from plastics as well, which could be poisonous. But let me clarify what pyrolysis is. So those fumes or those gases that comes out from the waste, the main problem is because of the combustion that happens. That is the reaction with oxygen. If it reacts with oxygen, it gets converted into the harmful gases or harmful fumes. But pyrolysis is a process where we do not supply oxygen. We treat it without having oxygen in it, so that it does not decompose into those fumable gases. Rather, it turns into other different liquids. So that is what the purpose of pyrolysis is. So we do not supply enough oxygen to it so that it will not produce fuel. So now let me share you the picture of pyrolysis. How does that look like? So the pyrolysis will look something like this. We will have a container and we will not feed oxygen to it so that it will not decompose into harmful gases.
Yes, but if I can come in again, at a point in pyrolysis starts with gasification, where you control the amount of oxygen that goes into the system. Fine. At a point in the pyrolysis, okay, during oxidation or reduction, oxygen must come in. So you see, we still have that problem. We have to be very careful with the fumes that must be generated.
Yeah, also there are many other technologies as well. Like I discussed about carbon capture And there is scrubbing technology that we can add after pyrolysis as well, from where we can convert that fumes that goes and we can dissolve those fumes into the liquid and have it safely disposed as well. So we call it scrubbing. That is the process by which we can make the gas that comes out. Where I think it is showing up the different image. So the main gas that comes is H2S as well, for which we can use scrubber. Let me show you the picture.
We have to invest in a lot of cleaning agents, scrubbers, cyclones, and all that. That's what I foresee with this kind of project. And of course, your gasifier will be very, very large. If you have to put in wood and you put in chopped pillated tires and other materials, your gasifier will be very, very, very large. And probably maybe it will be downgrade gasifier to be able to accommodate all this. Right. Thank you very much. It was a very wonderful one. Thanks.
Thank you very much, Francis, for that key contribution and comments. HP, you've been waiting. Please join us. Let me ask you to unmute. Oh, there you go. Perfect.
Are you getting me?
Yes.
Okay. I'm Herbert from Kampala, Uganda. My question is regarding yesterday's conference. Because of time confusion, time difference confusion, me and maybe there are some other members who missed the conference of yesterday. So I wonder if there's any chance whereby we can have the recorded other issues which was discussed yesterday.
Yes,
and also,
absolutely.
And also, as I'm winding up, as we have been told that this conference has been recorded, is there any way how we can get what we missed so that we can be on the same page? Thank you.
Yes, Herbert, thank you very much. Yes, we're preparing that, and we'll send it out we'll send out the link so you can rewatch today's presentation and also yesterday's presentation. And I also wanted to share with you guys that the idea is that at 10 a.m. Eastern time, which is New York time, we'll have a live session, hopefully several times a week. Tomorrow we have a presentation on statistics and math. On Monday, we have in psychology. Tuesday is human resources and leadership. Then we have psychology and pharmacology. Then we have database and web development. And we also have nanotechnology and materials science. So we have some very interesting and exciting topics that I can't wait to show you guys. And I wanted to really thank Manish for his time today and for bringing this excellent topic, and we hope, there's his contact info. Thank you very much, Manish, for sharing this.
I will love to hear any questions that you have in future as well. So there is my email, and I wish for a sustainable future for everybody.
Yes, and thank you for all the work you're doing, and students for all the work that you're doing, and for taking the AIU pledge, and we can all do a small part to achieve the sustainable development goals and generate opportunities for ourselves and for those around us that in parallel contribute towards achieving those. So thank you so much, everyone, for joining.
You too.
Thank you, HP, Arlito, Danielle, Mirable, Godwin, Alucine, Wishu, Elvis, Jonathan, Ricardo, Babatunde, Moses. Yes, please.
Yeah, I did write you on chat that I have a question. I don't know if I can make it.
Yes, please go ahead.
All right. The question goes to Manish.
Yes, please.
I first congratulate you on your idea. It's great. Okay. But I think we should look for the foreseen issues here. You create energy out of waste. I work for an oil and gas industry, so I work with these products on a daily basis. The first point which I'll highlight for you is the area you should have. You'll need huge area to accumulate enough waste to produce enough energy for at least a home. So that's one disadvantage. That's something we should have in mind. Another one will be how are you good handling these products, which can bring about diseases, contamination, and environment as well, which we should take care of. So something we should also have in mind. The third point, which I'll highlight for you, is what's the amount of waste you think we may need to have energy for a home? Let's say 100 meters space, a living area of 100 meters. How much waste do you think we need to have energy for this home?
That's a very good question and very good suggestions that like I agree, only 100% agree to your thoughts, and like we might need a huge amount of waste. And that's where I talked about energy density, and that is the problem. We might need a huge amount of waste, we might need to grind it, and we might, so there are different challenges. And talking about the contaminations and other problems that you rose up, so slowly the technology is going in the right direction, that they are more focused about the same issue that you brought up as well. There are few contaminations we should look into. And talking about how much waste should we need in order to have that would depend upon the application type of waste as well. So there are multiple parameters that could be like, we need to look into those for predicting the amount of waste that is actually needed for us to power a plant. But the idea is to create a economy that would be sufficient. For example, if you would like to have a house running with a sustainable energy, the idea is to make it sustainable with the waste that is produced, not by collecting the extra waste, but rather than the utilizing the waste that is available for us in order to produce that energy. Or the idea is not only to go like completely into renewable energy, because as the statistics, it's shown that only 13% out of 100% is focusing on renewable energy. The idea is just to use some part of the entire energy to reduce the effect of climate change and global warming. We are definitely not going to use 100% of renewable energy. That's not my point as well. But even if we could reduce the climate change just by 10%, that's a huge contribution to the earth and for the future generations as well.
That's a great point, Elvis. Thank you for bringing it up. And Manish, that's a good answer because, yeah, I mean, you might need to bring together the waste of 10 homes to be able to power one home because, you know, that's how much waste you need. But that's still 10% or 5% of energy generated from something that would have been garbage or would have been pollution is a huge win for humanity. So, you know, it's a piece of the puzzle. And I think, you know, all types of energy are a piece of the puzzle. You know, solar has its advantages, wind has its advantages and disadvantages. There's new storage opportunities like gravity. I don't know if you guys have heard of, you know, since solar energy and wind energy are sporadic, one way to store it is to lift heavy objects into the air, and that has a potential energy storage. And then when the energy is needed, we drop those objects and generate energy instantly. So thank you for that. Is there anybody else who wanted to contribute something for the presentation? Once again, thank you so much, Manish and students. Thank you for being here. Dr. Gonzalez, Dr. Freddy, Dr. Babatunde, thank you for joining us today. I see you as well. And I hope to see you again tomorrow morning. We have another session set up at the same time again. So, and we hope to have you back again, Manish. So we'll be in touch. And if you have other topics you would like to share with our students, we'd love to hear from you and have you back. Thank you, everyone.
Yeah, sure. Thank you, everybody. It was great discussing with you about